Hello, my name is Hayes Park, and this is Physics, Black Hole, and Orbits. The purpose of part 1 of this lab is to modify the star code, which simulates the interaction between a star and a black hole, to determine the black hole's mass. The system is the black hole and star, and the surroundings is space. In part 2 of this lab, the purpose is to simulate orbital motion in a planet-moon system and examine the effects of gravitational forces on a moving object. My goal is to achieve a H-shaped orbit while ensuring the spaceship is influenced by both the moon and the planet. In this part, the system is the spaceship, and the planet, moon, and space is the surroundings. Just a little preview, the mass of the black hole was 1.77 times 10 to the 34. The speed of the spaceship in the x directions was 24,750, and that's the same for y. Principles in this lab are Newton's second law, which is the interaction between the system and surroundings, which is the net force, to the observed motion, the change in momentum. From this law, we can get the position update formula and the velocity update formula. We also have F parallel, which is a force acting along the direction of the object's velocity. F perpendicular, which is the force perpendicular to the direction of an object's velocity. And then we also have gravitational force, which is the force of attraction that pulls objects that have mass together. We have the gravitational force equation right here. This is F net, was Newton's second law. Velocity update formula, position update formula, F parallel, and F perp in the code. These are both from the code. Procedure of part 1 of this lab was to find the motion of the star, its mass, delta, and etc. Find the initial and final velocity and the final initial momentum. Calculate F net, F parallel, and F perpendicular. And then lastly, find the mass of the black hole using everything above. And then part 2's procedure was to find F grab on the spaceship by the planet, find F grab on the spaceship by the moon, and find F net on the spaceship. Using F net, we find the position update and velocity update formula. And then lastly, find the speed of the ship in both the X and Y direction. This was the code I made in part 1. Gravitational constant was 6.7 E negative 11. Star's mass was 2.0 E 30. Delta's right here, time. And then you see F pair, F parallel, and F perpendicular. This was the end result of my code. We got an average mass of 1.77 times 10 to the 34. And this is what it looked like. A bunch of coding. This was my code for part 2 of this lab. You can see the position update and velocity update right here. This is all code. This was the end result of that code. We found the speed of the spaceship in X and Y was 24,750 ms, and this is what it looked like. It looks like an H shape. You see 1 and then 2. Some source of error that we could find in this code would be we are assuming that there are no other forces acting on the system, which is not the case in reality. There's definitely other forces acting on it. The speed of the spaceship was found through trial and error, so I had to keep trying to see which speed works best to give the best H shape. The velocities could be more precise. This was done through trial and error, and then the program could have ran longer in part 1 to get a more accurate average mass. So what does that mean for part 1? The net force and its parallel and perpendicular components, and the rate of change of momentum and its perpendicular and parallel components are the same thing mathematically, as you can see over here. But the thing that makes them different is one is easier to find than the other. It's easier to find the rate of change of momentum than it is to find net force, because you only need to change the velocity / motion. What if for part 2, if you wanted to predict the motion of an entire system, you would need to have all parts of the surroundings that are acting on the system in the computational model. So you can't just have like 1 or 2, you need like all of the surroundings, all the surrounding forces.